what I did was I went ahead and I wrote down the formulas for the difference of squares, the difference of cubes, and the sum of cubes. So these were the two here that I couldn't remember. And this is probably why. This is just a crazy formula that you don't really use that often. But so if you have a difference of cubes, um, you'll have a subtraction. Difference means there's a subtraction. So you have the difference of two cubes, and this is the formula. So the A, it's A minus B, and then all the rest of the terms are added. Then you're left with A squared plus A times B plus B squared. And then the sum of cubes, so now if you're adding two cubes, it's instead of A minus B, the first factor is A plus B, and the second factor is just like this, but the first time, the first term you subtract after the first term. So it's A squared minus AB plus B squared. So it's just a crazy formula, and it's just best to memorize it. And that's why before, when I was doing the lesson with Gabriella, and I did get this long trinomial here, and I had completely forgotten that that's what you get when you have the sum or difference of cubes. So, and then the difference of squares is that's going to be usually what our second term is the difference of squares. So that's just, you have two numbers and they're both squares, and the difference of squares is you add the A and the B in the first factor, and then you subtract them. It's A minus B. So that you'll see a lot. So let's go ahead, and this was the example in your book, and they said to find the least common multiple of these two expressions. So when they're asking for the least common multiple, they want to know what number, and the number is going to just look like a bunch of factors, but what number will both of these expressions go into? So the way that you have to solve for least common multiple in algebra is you first have to factor each of the expressions. So that's what we're going to go ahead and do. So right now we'll just look at the first expression, and the first thing you want to do is try to factor out a constant. So we'll take and factor a 2 out of both of these terms. So 2 comes out of the 2p cubed, and you're left with p cubed. A 2 comes out of 54, and you're left with 27. Negative 27, because it was negative 54. So that's fine. And so we just left this one alone for right now. But now it looks like this might be a cube, a perfect cube. So let's show it as a perfect cube in the next step. So the p cubed stays the same, and 27 can be rewritten as 3 cubed. That's a perfect cube. 27 is a perfect cube. So now we have the difference of cubes, so we can use this formula up here. So let's label what is our A and what is our B down here in our problem. So P is going to be A and 3 is going to be B. So now let's use the formula. The formula said that the difference of cubes is just A minus B, so it's P minus 3 times, now we have this huge trinomial. It's going to be times A squared, so times P squared, plus A times B, so P times 3, and I'll switch those around so they look better. I switch them down here. So it's a times b plus b squared. So plus 3 squared. So that's what you're left with. So if you took this whole trinomial and multiplied it by p minus 3, you would get back up to here. And you can do that and just to check and convince yourself that that's true. You'd have to take the p and multiply it by each term of the trinomial, and then take the negative 3 and multiply it by each term of the trinomial, and then add all your like terms, and things should cancel, and you should end up with this. But for right now, you could just take my word for it that that is the formula. So this one is completely factored, this difference of cubes here. We can't factor this anymore. And so let's look here, go back up here, the p squared minus 9. We want to show p squared minus 9 as a difference of squares, because you should recognize that 9 is 3 squared. So let's show it that way. And so this would be our a, and this would be our b, and the formula for the difference of squared is just a plus b times a minus b. So that would be p plus 3 down here times p minus 3. So now both of our expressions are factored completely. So now what we do is to find the least common multiple of these two expressions. In other words, what number, and here's the answer down here, can each of these expressions, or let me rephrase that. So the least common multiple is the smallest unit that each of these expressions can go into. So that's the least common multiple, and I'll just write that over here. It's the smallest, I'm just going to use the word unit, because sometimes you're dealing with fractions, sometimes you're with fractions they call it the least common denominator, but we're talking about whole numbers now. So the least common multiple is the smallest unit that both expressions can go into. That should probably be one word. Can go into. Okay, so the way that you find the least common multiple is, and I wrote it over here, the least common multiple is, first of all, you look at the factors, the common factors of both of our expressions. Well, here's one expression, okay, and then here's the other expression here. So what's common between those two expressions? Well, I wrote what's common down here. The p minus 3 is really the only factors that both expressions, or both, actually now it's a conglomeration of expressions. So I'll say the left side and the right side. So the p minus 3 is the only factor that is common to both the left side and the right side. So we're not going to repeat that factor. Anything that's in common right here, these two are in common, so we only write them down once for our least common multiple. So we just kind of start out, writing, and just remember that the one that's highlighted in red only gets written once. So I just started writing the 2, the p minus 3, the p squared plus 3p plus 9, the p plus 3, and then I stopped because we're not going to rewrite this again. So this is our least common multiple for these two. Well, up here they were expressions. Down here they're factored out. So like I said, I'm just going to call this the left side and then this the right side. So that's that example from your book. And then, let's see. Let me get to the other one is here. So then here's the other one. Whoops. Let's move this over. Okay. So these were your two expressions. Whoops. Don't want that. I'm not sure how to get rid of that. Okay, so here's your two expressions here. And find the least common multiple. So we want to find the number, which here's the answer down here, that both of these can go into. And you can see that, well, you can't see it yet. You'll see it when we get down here. So we won't skip ahead. So the first thing we do is we have to factor a 3 out of the first expression, because you can see that we can factor something out of this expression. You just want to get things as simple as possible. So factoring a 3 out of this first term, we're left with d cubed, and factoring a 3 out of negative 24, we're left with negative 8. This one I didn't do anything to. And then down here, we want to show that the first expression is a difference of cubes. And we want to show that the second expression is a difference of squares. Well, why do we want to show that? Well, because I can tell that, 8 is 2 cubed. And we already have a cube here, so let's look for a cube here. And voila, we're so lucky that we do get a perfect cube. And then on this one, we have a d squared, and wow, we're so lucky. 4 is a perfect square as well. So let's show that down here in 2 cubed. I wonder if I can make this bigger, but then I might not be able to get the whole thing in. Okay. Good. So that's what we want to do. We want to show that this is a perfect cube, and so now they're difference of cubes, and these are both perfect squares, so we have a difference of squares. And then let's label them. So then let's use our formula. And I don't have the formula on the screen, but this was your A, your B, here's your A, and then here's your A times your B, and then there's your B. So the A was squared, and the B was squared, and that was subtracted, and these were added. So there's your formula there for the difference of cubes. And the difference of squares is just easy. You add one and you subtract the other. So let's go ahead and write this out, the difference of cubes. So it's d minus 2, so it's A minus B, and then A squared, so our A was D squared, plus D times 2, A times B, plus B squared. So there's our B was our 2 plus 2 squared. And then here's our difference of squares. So now we're done factoring it. We can't factor this anymore. And so let's go ahead And let's, oops. Let's go ahead and let's highlight your common factors and only use them once when we write down our LCM. So our common factors you can see are d minus 2, d minus 2 over here. I don't see any other common factors. So we just go ahead and we start writing. So we got 3d minus 2, d squared plus 2d plus 4. I changed that to a 4. And d plus 2. And then we don't write this down again. We only write it once. So that's it. That's our least common multiple. And so you can see, now that they're all factors, you can see that, yes, in fact, this entire set of factors will go into our least common multiple. It will go into it. The 3 will go into that. The d minus 2 will go into that once. This will go into that once. The d, or that's the end of that one. And then at the same token, you can see that this set of factors will also go into this least common multiple. The d plus 2 goes into here. The d minus 2 goes into here. So there you have it. There's your least common multiple. So I hope it's understandable for you now that you have the video and you also have, you have these sheets also that I sent to you.